Hi all, so today's lesson is on linear programming, and linear programming is basically solving a system of equations, and within the shaded region we want to find out what makes a max profit based on the constraints we're given. And so first we sketch out the equations, find the vertices, and then we plug in our vertices into our maximum objective function, or sometimes, like in context of a problem, it's called the profit equation. So in this first example, we have these four constraints. So x is greater than 0, y is greater than 0, and then I'm going to change this third equation into y equals mx plus b. Oops. So that would be y is less than or equal to negative 1/2 x plus 2. And then this one would be y is greater than or equal to x minus 1. So plotting these, we would get an equation here. And then the second equation starting at, or the first equation down 1/2. And then the shading, so I'm going to plug in the point 0, 0. And so I would get 0 is less than 2. That's true, so I'm going to shade where the point 0, 0 is. And then we have 0 is greater than or equal to negative 1, which is true, so I'm going to shade where that point is. So our double shaded area would be this region here, and I'm only including this here because remember we're at x is greater than 0 and y is greater than 0. So the vertices that make up this shape are 0, 0, 1, 0, 0, 2, and 1, 2. We're going to plug these all into the objective function, which is 3x plus 2y, to find the max, which is z. So 3 times 0 plus 2 times 0 is 0. 3 times 1 plus 2 times 0 is 3. 3 times 0 plus 2 times 2 is 4. 3 times 1 plus 2 times 2 is 8. So our max is 8. When x equals 2 and y equals 1. Moving on to the next example. So I'm going to change these to y equals mx plus b form. Y is greater than or equal to negative 1/2 x plus 2. Y is greater than or equal to negative 3x plus 7. Y is less than or equal to 1/2 x plus 3.5. I'm going to go ahead and plug in 0, 0 now. And that's not true. 0 is greater than or equal to 7. Not true. 0 is less than or equal to 3.5, which is true. So let's go ahead and graph these and include our shading. So starting at 2, and then going down 1/2. And connecting our points. And then starting at 7, and then going down 3/1. And let's add the shading in on these. So the first one, when 0 wasn't true, so we would shade this side. The second one, 0 wasn't true, so again we shade this side. In the last equation, starting at 3.5, so 1, 2, 3.5, going up 1/2. and 0, 0 was true, so I'm going to shade according to that line where the point 0, 0 is. So our triple shaded area, where all those 3 shades are, is right in that middle piece here. Okay, and the vertices that we can see that make up that figure are 1, 4, 2, 1, and 1, 2, 3, 4, 4, 0. So we're going to plug those into the objective function, which is 4x plus 2y, to get the max. So plugging in 1, 4, we get 4 plus 8. 2, 1 would be 8 plus 2. And then 4, 0 would be 16 plus 0. So right now it looks like 4, 0 is the max. But let's try and just plug in another point that's in that shaded area, because this isn't only restricted. This shading goes on infinitely. So let's just try 5, 4. We would get 20 plus 8, and that's 28, which is greater than 16. So you can see here that there's going to be no max because this shading goes on forever. The other way to see these problems is in a word problem. So here we are talking about 2 types of boxes of chocolates. There's the cream box of chocolates, so we'll call that X. And then the nuts, so we'll call that Y. The profit would be because of the cost of them, so 1.5x plus 2y would give us the profit. These constraints, so the combined production level should not exceed 1200, so x plus y should be less than or equal to 1200. And then the second one, the demand of box of nuts is no more than half the demand of box of creams. So y is less than or equal to 1/2 x. And then the third one, the production of creams should be less than or equal to 600 boxes plus 3 times the production of nuts. So x is less than or equal to 600 plus 3y. I'm going to go ahead and put these all in y equals mx plus b. X plus 1200. This one's already in y equals mx plus b. And this one would be y is greater than or equal to 1/3 x minus 200. So when we go to plot these, one equation would be here, and these numbers are by hundreds. Just didn't want to write and take up all that space. Here's one equation, and then 50 out here, and then the last one 1200 and 1200. And after you do your shading, in this region here would be where the triple shade is. So our vertices are 0, 0. And we have this point here, which is 800, 400. This one here, which is 1050, 150. Oh, can't write today. And then the x-intercept, which is 600, 0. Then our profit equation was 1.5x plus 2y. Z. So we would get times 0 plus 2 times 0, which is 0. 1.5 times 800 plus 2 times 400, which is 2,000. And then 1.5 times 1050 plus 2 times 150, which is 1,875. And lastly, 1.5 times 600 plus 2 times 0, which gives us 900. So our max is 2,000. So in context of the problem, X was the cream chocolates, so 800 creams and 400 nuts for a profit of $2,000. And that's the end of that one. To find those points of intersection, just remember you're solving a system of equation where you can set the equations equal to each other and solve for the point of intersection, just to go back to how I got those originally. If you have any questions, just let me know.